class, we worked on transformations of quadratics. Transformations is the same thing we've been doing for several lessons now. So this time I gave you the coordinate rule, like what we put in our new tables. I wrote that for you. I wanted you to go backwards and write the equations. Anybody got an answer for number one? Yeah.
Y is equal to 5, and so 1 by 2, and so x plus 3, whole squared plus 2.
I think so. Like this. 1/2. Okay? So again, you know that A and D transformations affect your y. So since it said 5y plus 2, I knew that these had to be there. And then the B and C affect your x's, and so I knew what those had to be. But remember, B's and C's are opposite. With B's, it's the reciprocal. With C's, it's the sign. So this is what the equation should have been, and then I listed what my transformations were based off of that. And then there's the second one. I didn't mean to put that one up already. But knowing that, again, you can go backwards from that. Do we agree? So we normally have, like I said, here's the equation, write the stuff. Here's the equation, write the stuff. I thought this was a good, just like, hey, I'm going to give you the stuff, and then you write the equation. So it's going backwards a little bit, okay? We've got to know those transformation rules, like, by heart, okay? Because they are not going away. Okay, before we jump into the lesson, let me go to the calendar. So you should have gotten two different things last time. You should have gotten your packet, which was this color, okay? So we're going to be working in this today. You should have also gotten your homework packet. Let me just, in case someone gets lost, show you on Canvas. The notes packets are always linked in Canvas. The practice packets are also linked there in case you lost that. I do have a Delta Math assignment that should be up there already. So for the rest of the lessons in this unit, I did set it up to where you can put your answers to the practice packet in for that feedback. Unfortunately, though, on October 23rd, Google is doing something weird, and y'all aren't going to be able to log into like a lot of stuff with your Google accounts anymore. I just found this out Friday. I've been freaking out. Of course, Delta Math is one of those things that you're not going to be able to log in on. So I guess it's good that we already have paper practice for you, because I don't really know what's going to happen on October 23rd as far as
No school.
what that looks like.
We're deleting
Okay,
Google.
do what? No, it's... Okay, so keep listening. So, yeah, I don't know. To be determined. But all I know is that we are going to be able to use Delta Math until the 23rd, and then at that point, I don't really know what capacity we will use it in, if at all. This is upsetting to me, and I don't know if y'all care, but it is upsetting to me. So here's what we're doing today. We're going to work on 3 forms of quadratics. You will have a check for understanding on Friday. That check for understanding is going to have a little bit of transformations on it, kind of like that practice on there. Like you're going to have a graph, some writing, and then it's also going to have a couple questions from today's lesson. And today's lesson is stuff that you should have learned in Algebra 1, and quite honestly, it's like my favorite lesson to teach of all time because I love quadratics. But that's what we're going to do, okay? Back to quadratics. So, quick refresher. This is what we did before the long weekend. We talked about transformations. Remember, we have quadratic equations, parabolas. We talked about the parent function and all the features. We need to know all of this. Your CFU, you're going to need to know all of this. How to transform. This is your notes from last time. How to transform, how to write. Here we are here. Okay, page 7. Bless you. Page 7. Okay. This should be sort of familiar. A lot of stuff that I say today should be familiar because you have learned this way back when. Okay. 3 forms of quadratic equations. So this is supposed to be an Explore thing. I forgot to tell y'all to get a calculator, and also I don't want you to have one for most of the day. So are we going to be upset if we just use my calculator right here? Yes. Don't be upset. Okay? All right, so here we go. I'm going to put these 3 quadratic equations, which look nothing alike. Can we agree with these right here, what I'm typing in?
Pretty unfamiliar. Similar.
They look nothing alike. They are not similar.
You literally just press Y
Okay.
equals, because that's what it is. Yeah. Y equals. He didn't know what to do.
Okay, so I put my 3 different quadratic equations, which we can agree they do not look the same. Okay? One has 2 parentheses, one has parentheses squared, one has no parentheses. All right, I'm going to graph it.
What have I done?
And here we go. Here's the first graph. There's the first graph. It's a parabola. Here's the second graph. Also a
Yo, are they
parabola.
exactly the same?
Yo, what?
How are they exactly the same? They
Another
are
parabola.
all the same.
Oh my goodness.
Okay? So, mind blowing.
What?
So, all of these equations are the exact same. They do not look the same when you look at the equation, but what we're going to talk about today is each form tells you something specific, and then we're going to spend the next 3 days, okay? 3 days converting between all the different forms, all right? And we've got a lot of foundational skills coming up in the next 3 days, and also an entire test topic. So, what those 3 forms are right here. This is a screenshot that I stole from Google. But these are the names of these 3 forms, okay? You are going to need to know the names. You're going to need to know the attributes. And you're going to need to know some of the things that they have in common. All right? So we will start with vertex form, this one right here. I'm going to start with this one because technically this is kind of your transformational form. They don't put the B value in there, and that's okay. It's fine, because usually when you deal with this, you don't have a B value. But the giveaway that something is in vertex form is that it's always going to have a parentheses squared. So if you ever see an equation and there's a parentheses squared, like that's telling you, hey, it's vertex form, okay? And this one, I think, is really straightforward enough. Because in vertex form, you can see the vertex. It's in the name, okay? So that's what you can see in there. And they kind of wrote it right here. And we talked about this already. You should know this just from Transformations Day. That the H, which this is why they use H and K. Because if you Google what is vertex form of a parabola, it will have H and K in there instead of C and D. But they're in the same place. They do the same thing. So the H value, the number inside the parentheses squared by X, is the X value of your vertex. But remember, anytime it's coming from a C value from inside, we always have to flip the sign. So you flip H, I'm going to write that, flip sign. And then the K value, which is not in parentheses, you do not flip that. So a lot of times I say flip and keep, because K starts with keep. But you can grab that vertex point. We did this last time, nothing new. But that is truly what vertex form tells you. And we need to be able to go I give you a vertex, you put it in an equation. Or I give you an equation, you tell me the vertex. That's kind of the goal of what we're doing today. What can you see and how can you go backwards? So that's vertex form. It's your transformational form. The next form is standard form, which looks like this. Y equals ax squared plus bx plus c. There's no parentheses in standard form, okay? They will have none. Standard form, to be honest, is not really that useful. There is only one thing that you can see in standard form. Y'all know what it is?
Y-intercept.
The y-intercept, and it is the ordered pair 0, c. Do we change the sign when we grab c?
No.
No, because is it in parentheses? No. Okay, and then why is that? Why is that last number, that constant, why is that going to be your y-intercept in this form? Yeah.
Because that's where you would up or down.
That it, well, not in this form. Not in this form. It's not how you move up or down. When do y-intercepts happen?
When the line goes through the Y-axis.
When the line goes through the y-axis, what's the x value every y-intercept? 0. If you put a 0 right here, what is that term always going to be? No matter what's in front of it, 0. What is this term always going to be? 0. 0 plus 0 plus c is going to be c. So whatever, because it's a y-intercept, wherever you would have an x, which are these 2 terms, those are going to zero out, and it's always going to be that last number, just whatever it is. Positive, negative, no sign flip, that's your y-intercept. Not hugely important it's a feature, it's an attribute, but there's just not a whole lot that you can see from standard form that's super useful when it comes to graphing, but it is a good thing to check. And then the last one is, I don't really call it intercept, I mostly call it factored form. Factored form typically is going to have 2 sets of parentheses. This is the one that you should have seen a lot in Algebra 1, and this is the one that you're going to keep seeing all year, really, because you get that by factoring, which that is coming. We'll do that next week. And in factored form, you have your 2 sets of parentheses, and each parentheses is a factor. It'll be x plus or minus a number. And those numbers, which this form called P and Q, sometimes they call it like R1 and R2. Because what are the other names for x-intercepts? Roots or zeros or
Rules?
solutions.
What's rules?
I don't know what rules are.
What are you talking about?
Roots.
Solutions.
Okay? So each of those numbers that's in that factor with x is going to give you an x-intercept. Remember, that x-intercept's happening when the y value is 0. Now, both of those, we'll call them P and Q for now, just because that's what they're written at. P and Q are both in parentheses. So what are you going to do with those signs when you take them out of the factor? You've got to flip. So I'm going to write flip again. Flip. And when I say flip, I guess I should write sign. Flip sign. Flip sign. So in factored form, you can see those x-intercepts. Standard form, you can see the y-intercept. Vertex form, you can see the vertex. Okay? So going back to that little explore that I did for you, I want you to tell me what each form, it gave you the form already, so that should help you. And I want you to draw me an arrow to what attribute that's going to tell you, and then tell me the attribute. Go back to the top. Draw an arrow. Factored form is going to tell you what?
Vertex.
Try again. So I'm going to draw an arrow there, and then I want you to tell me what those are. That's all we're doing right there. And then put all that information on the graph, sketch a graph. What are the roots? Negative 3, 0.
3, 0, 1, 0.
Positive 1, 0. Very good. You could tell that from your factored form. So I drew an arrow from there. What is your vertex?
Negative 1,
Negative 1, negative 4. Good. Flip and keep. And then what's your y-intercept? 0, negative 3. Okay, so you put all those on the graph. It makes a nice, pretty parabola. The extra stuff. What was the AOS? X equals negative 1. You've got to put x equals. Domain? All real numbers. Range? Negative 4 to infinity. Some people like to write y is greater than or equal to negative 4. That's fine too. Okay, either one is fine. One more thing about these 3 forms. Question? Yeah.
Okay, so for the vertex, the y-intercept,
Mm-hmm.
can you place another dot, flip it, if that makes sense, you know?
Oh, yeah. The symmetry?
Like that.
Yes, you can use that. Because remember, that's what that axis of symmetry is about. So yes, absolutely. Okay, hey, thank you for bringing that up. Listen, okay? There is symmetry in parabolas. So you can have what we call like symmetric points. Your roots are symmetric points. Because what is the y value of both of your roots? 0. Here's what's cool. All of your symmetric points that have the same y value, they are equidistant to that AOS. So if I know that my AOS, if you look, here's my AOS, I'm 1, 2 away from this root, left 2 away from that root. I'm 1 away from the y-intercept, so you're right. There is going to be a point, and you could put it on there if it helps you, like, connect your points as well. That's what all that symmetry is about with quadratics, and so that is really cool. And we will use that later today, okay? Last thing before we move, I forgot to mention this. What's something that all 3 of the forms have in common?
X.
They have x's, yes. They have y equals.
Hey.
That A value is going to be the same number in every single case. So what was the A value in our first example?
Nothing.
Not nothing. 1. Okay?
One.
That A value will tell you how your graph opens. Okay? What the concavity is. So I'm going to write, how did I write this? Your A value. This is important because we're going to have to calculate our A value in a little bit. So that A value tells the concavity. So if it is a positive A value, then that means your graph is going to open. What do you think? Up. Okay. If it is a negative A value, that means your graph is going to open down. If it opens up, does it have a minimum or a maximum?
A minimum.
Minimum. If it opens down, it has a maximum. I will ask you that on the next couple of pages. So you'll want to know. Again, you're just looking at it being like positive or negative. And it has to do with, that's the same A value in transformations, if it's been reflected or not. Okay? All right, so flip over. You're going to see kind of a lot of redundancy today. Well, mostly on the next page. It's all good. This is how it's going to be more kind of, we've actually kind of answered some of these questions, but we're going to do this number 1 together, and then you're going to do the next 3 on your own. Okay, this time I need you to tell me what form it is in. You've got to know the names of the forms and what attribute do you see and actually identify it. Okay, so if you're confused, listen to me on number 1. If you got it, you got this page, and then stop at the next page. So y equals 2 times x plus 6 times x minus 2. What is that in?
Intersect. Factored.
I like factored form. This is our factored form. Because how many parentheses does it have? 2. So 2 sets of parentheses. What attribute do you see in factored form?
Roots.
Your roots. Also could say x-intercept, 0 solutions. I'm not picky about the vocab. What are those actual roots on this problem?
That would be,
Negative 6, 2.
Negative 6, 0, and 2, 0. If you don't, I prefer y'all to write them as ordered pairs. If you don't do that, you also could write it as a set, negative 6 and 2, but you have to use a squiggly bracket there telling me that it's like a set of x's. Or you could put x equals or x equals. I prefer ordered pairs. If you don't like the squiggly bracket, don't do it. Just write the ordered
I
pairs.
will not be doing that.
Okay? All right. 2 times x plus 2, quantity squared, minus 32. What form is that in?
Standard.
no, it's the vertex.
What?
Vertex.
Oh, I'm on the wrong.
Vertex. So what can you actually see?
The vertex.
Go Santo class.
The vertex, and what is it?
It's minus 232.
Negative 2, negative 32.
Goofball.
Okay? What form is the last
A little
one?
bit late. Sorry,
Standard.
Matthew.
That's your standard form. So what do you
Line
see?
set, line set, line set.
Light and
And that is the point.
negative 20.
0, negative 24. That's the point. Okay? What's the A value in all of these?
2.
Positive 2.
Positive 2. So what does that tell you?
Positive 2. Pal.
Graph is
Opening up.
concave up.
Concave up has a minimum.
Concave up
Minimum.
has a minimum. Okay, you do 2, 3, and 4. Star this. I like these questions. These are good types of questions to really make sure you understand the 3 forms. And then we're going to get to where we have a little more algebra and we're going to be writing the 3 forms. Okay, so we're kind of on cruise control right now.
Attribute.
So do those. Okay, all right. Here are, y'all check my work too because sometimes I'm crazy. Did y'all get matching?
That's wrong.
It might be.
No, it's not.
Embarrassing.
Hopefully not. Okay? So, this is not if, this is when. You're going to CFU next class. You're going to have questions kind of like this. What form is it in? You've got to know the name. What attribute? You've got to know what attribute means. What does attribute mean?
It means what it is. What does
It's like
it
a
show?
characteristic. It's a characteristic. Okay? Well, in this context, I mean, what attribute do you see? But just in general, if I ever say, tell me the attributes of this, I'm talking about just those key features. Those things we keep finding. Okay? That's what that means by definition. And then tell me actually what it is. what's the concavity based on the A value, okay? You don't have to write A equals, that's just, I put that there so I knew like what I was looking at to tell me the answers to those, okay? So I start this is important. These are questions that if they were on like when they are on your real assessment, there's not partial credit. It's right and it's wrong, okay? So you have to know that because there's really not a whole lot of work to be done with these, okay? This is still Algebra 1. Anybody remembering it from Algebra 1?
My teacher not teaching it as well because.
I remember not grasping
Well,
the
thank you
concept
for telling me
of
I'm teaching it well.
I remember.
Okay? Is that what you're saying?
Yes, actually.
All right, next page. Algebra 2. Next page is Algebra 2. Next page is Algebra 2. Next page, I be putting some stars on number 5 and number 6. Star and star.
Star for the CFA
Okay.
or star for the test?
Probably both.
All of the above.
So
All of the above.
here's the thing on these two questions. In the notes, we gave you a lot of little things to circle, things to like, what form should you use? What are you given? That type of thing. On CFUs, homework, test, I'm not going to give you any of this stuff right here. No. I'm going to give you a problem and I'm going to give you an answer blank. So we're going to use this as we process through, but I want you to watch how I'm processing. This is kind of what we're trying to get to. I show you how to process and then I'm going to throw you in the deep end, make you figure it out, okay? But you have a model. You have a model. You have a model, okay?
Good job,
Yes, that's what I'm saying. Just drop them in. And
Yes. No, okay, I'm not totally dropping you in. You have a model. Like, so I need you to, like, watch how I'm processing, and then you process. All you people on your Chromebooks, close them. I see you. Okay, here we go. Write the quadratic equation with the given information. Passes through the point 124 and has zeros of 5, 0, and negative 1, 0. Okay, so what attributes did I give you?
X-intercepts.
X-intercepts, which are zeros, root solutions. You need to know all those vocab words, okay? So knowing, you got to recognize what you're given. Did I even have to put the word zero there?
Not really,
Why not?
because that's what it is.
How do you know that these are zeros?
Zeros.
The y value is 0. So if I didn't tell you it was a 0 and I just said, here's your points, you should know what to do. Hint, hint.
That's a good solution.
Okay? So if we know that the x-intercepts from a problem, then what form should we be writing in?
We should be writing in factored form.
We should be writing in factored form. We want to work smarter, not harder, people. In the back, y'all with me? Y'all awake?
Let's be smarter.
No.
Okay? So I'm going to start by setting up my factored form, but there's some information that I don't know. For instance,
Thank you, Dogan.
how do you find the A value? Well, we're going to find it, but for right now, I'm just going to put A in the very front because that's always where it goes in all three forms. Okay? But then I'm going to write my factored form, which is 2 sets of parentheses. Both parentheses start with X. Every parentheses will start with X, whether it's a squared or it's doubled. And then I need to put my roots, zeros, x-intercept solutions, I need to put those into my factors. So I'm going backwards. If the root is at positive 5, my factor is x minus 5.
Good job.
If the root is at negative 1, my factor is x.
So minus 1, actually. Wait, but that was the thing.
You got to flip it.
You have to flip both of them?
Any time it goes in parentheses, we flip.
Hold on.
Okay?
No, that's wrong.
That's right. Okay, so at this point, hey, am I done? Do I have an equation that goes through those zeros, but also through the given point?
You don't have the A.
I don't have the A.
How do you feel about the yellow?
So in order to make it go through this random point, I have to figure out what A is going to make that happen. This is Algebra 2. What do you know anytime you're given a random point?
Plug it in.
You're given a X value and a Y value. You have X value
I feel proud.
and a Y value in your equation, don't you?
Indubitably.
Here we go.
Now I know where to solve this.
24 is equal to A times 1 minus 5 times 1 plus 1. Okay? You have to use a point that is not one of these attributes. Okay? What?
How'd you get 24? Oh my gosh.
Oh my gosh. It's in the
124. Okay,
value.
We're not going to make fun of questions.
Not yet.
I'm making
It's from the point. It's from the point. Y'all, you have to have a point, and it cannot be one of your attributes. Like if I'm using factored form, I am not allowed to use an x-intercept as my plug-in point. I could use a vertex, I could use a y-intercept, I could use any other point, but I can't use like what form I'm writing in, what that shows me. Does that make sense? Okay? Okay, so now let's clean it up. What is 1 minus 5?
It's negative.
So I have a times negative 4. 1 plus 1 is?
2.
Okay, this is a big multiplication. What is negative 4 times 2? I'm going to put that in front of a because it's a times. Sometimes I feel like if you keep it behind, I mean, if you put parentheses, it's fine. But sometimes it looks like a minus 8, and it's not. It's negative 8 times a equals 24.
A equals negative.
And now I'm able to...
No way.
Magnificent.
This is truly just
Truly magnificent.
beautiful.
Wow. Oh my.
So now I have all the puzzle pieces. Y'all, people totally forget to go find the A value. And they just like either leave it as A, which is even more embarrassing, or they just assume that it's 1 or something.
What?
You need to make sure you go and solve it every single time. X minus 5, X plus 1. Here is your equation. Now, I am not going to tell you what form to use,
No.
which means technically there can be more than one answer, but I'm going to tell you right now, I want the most obvious one, which is, what do I give you? I give you the zeros, I want the factored form. I give you the vertex, I want the vertex form. Okay? Converting is like a whole other thing, which we'll spend some time doing that. Okay? So, knowing what you know, I want you to try to do number 6.
No.
Oh, I think it's vertex.
It's a little bit different, but I think you got it. So, thinking about this problem, again, your instructions are just going to be write me a quadratic equation. Think about what you know. Think about what's going to be smartest. Now, I will warn you, like I talked about with the zeros, I may not label that it is a 0, but you will need to know zeros are zeros, or roots, x-intercepts, because the y value is 0. I have to tell you if it's a vertex, okay? Like that will be labeled. It is a vertex, here's a point. And that's all you need. So what form should you be writing this equation in?
Vertex.
You should be writing in vertex form. Will you need to solve for A? Yeah, every time. So do your setup. Remember, this is your H, this is your K. Vertex form has a parentheses squared. You put the X value of the vertex in the parentheses, but whenever it goes in parentheses, what do we do with the sign? Flip. The K value is not in parentheses, so it does not flip. Okay? You need to be able to get at least here. If you don't know how to get here, this is Algebra 1. Algebra 2 is, okay, what else do we want it to go through? X value of 2, Y value of 5. So now you plug it in.
Uh-oh.
We have not done that.
We have not done that.
No, he hasn't done that.
Big brother in it.
What's 2 minutes?
What kind of tomfoolery do they have to
The solving for A is a slight bit different just because of the way vertex form is set up. So if you are confused, you will have to do this. Ask a question. Watch me now. So this is 5 equals 2 minus 4 is minus 3. What is negative 2 squared? 4. I'm going to move the 4 in front of the A. Again, I like to have it as like the coefficient times A. With solving for this, you would have to add the number, divide, thank you.
I'm aware. I thought that you could like subtract that from the 4.
5. 5.
What? Forward. Does anyone have questions about 5 or 6? Yes.
Yeah, it's fine.
Why did I write f of x? Good question. Because you can. If you want to write y equals, you can write y equals. I just wanted to show you that to remind you that it still is quadratic. It still is a function. Not going to be picky about that. Okay? But I will tell you, you do have to put something equals. Okay? Y equals, f of x equals, g of x equals. I will take points off of your test if I ask for an equation and you give me an expression. Is this an equation? What I'm showing right there? No, that's an expression. Is this an equation? Yes. Okay, but you can pick what y equals f of x, g of x, whatever. Okay? No. We can do y equals or we can do f of x equals. How about that?
What about W? I really like
No, unless I tell you that it's named W, no. Okay, flip over. Number 7, page 10. This last problem. And then you're going to get plenty of homework time, and you better be getting all your homework done for today.
I have
Okay?
to prepare myself for Chick-fil-A.
You have a CFU next class. So, situations. We're going to do more situations when we get into the second half, not of the unit, the second half of our quadratics. So there's 2 units on quadratics. But there are a lot of real-world applications. However, a lot of times the numbers are not so pretty. So we found one that we could do without a calculator, kind of like start talking through it. It's really good for 3 forms. But for the most part, you're not going to have so many scenarios in this chunk of the quadratics unit. But regardless, here we go. A toy rocket takes off from the ground and peaks 1,600 feet off the ground after 10 seconds. That tells you something. Graph this situation and label significant points. So there are 2 significant points that situation told me. What are they? 0, 0 is one of them. How do you get that?
Because that's literally where it starts.
Starts on the ground. Okay, 0, 0. All right, peaks.
0, 1, 6.
That's telling you that is a
Y
maximum, which a maximum is a vertex. This is your vertex point. Now, which way do you write it?
in vertex form.
Well, we will get there. But how do you write that point? 1,600 feet after 10 seconds. What is our x going to represent?
It's going to be seconds.
Seconds. What is our y going to represent? So how would I write that as an ordered pair? 10 seconds, 1,600 feet. Okay? And this, again, is a vertex point. What is 0, 0? It's actually 2 things.
That is the origin and the x-intercept.
It's an x-intercept, and it's also your y-intercept. It is the origin. But it is, if you use the origin, it is the x and the y. Okay? So how many forms are we going to try to write? 2. What's one of the forms going to be?
Vertex.
Vertex form, because what do we know? We know the vertex. What's the other form?
Standard. Because we have the y.
Standard, I haven't showed you how to write from standard yet. We can, and we can try it. But the other one we need to do is,
Factored. Wait,
Factor.
the y factored though.
well, what else do you know?
Well, the x
Oh, we know the
intercept.
x-intercepts.
But we also know the y-intercept though.
Correct. But, okay, here's the thing. In factored form, in standard form, ax squared plus bx plus c, there's, c, but that's about it. You can find a, but you don't know how to find b from there. We can, if we find these 2, we can convert it. But we want to know based off of what these roots are. So I see where you're going, but I'm going to slow you down for a second. We're going to focus on these 2, okay? But we only know one of our x-intercepts. But, Will, to answer your question, yes, we can assume there's going to be symmetry in this. So here we go. Let's put our graph on here. How do I want to? We're going to count by 5s on the x. So 5, 10, 15, 20, 25, 30. And I counted by 400s on the y. 400, 800, 1,200, 1,600, 2,000. And then I'm going to plot. I take off from the ground, 0, 0. Peaks at 10, 1,600. So that is my vertex, also where my axis of symmetry is. So remember what I said about being equidistant, symmetric points. X-intercepts are always going to be symmetric points because their y values are always 0. They are equidistant. to the AOS. So if I go take 10 seconds to reach my vertex point, when am I going to land? How many more seconds? 10 more seconds. So I land at, what's my other route? 20. No, 20, 0.
Oh, my bad.
So now you have both of your x-intercepts. That's why we're going to go to factored form first. Okay? What are we missing?
A point.
We need our
Need
A value.
That's so right.
Okay?
Need the A.
Oh my gosh.
Well, same thing.
Matthew.
So here's my picture. Ooh, this isn't a great picture.
That's
We
what
gotta
we're
find it.
We
out.
gotta find it, bro.
Okay, so here's where you have some leeway.
I have.
You
I
can.
have.
Do y'all want to start? Do y'all want to calculate A from the factored form like we did on number 5? Or do you want to calculate A from the vertex form like we did on number 6? Because we can do either way. Which one? Which one was easier? I think factored form was easier. You don't have to square, you just multiply. Like, I would prefer calculating A from factored form. That's just me. Could you do it from vertex form? Yeah, because you know the vertex. But I'm going to find my A from my factored form. So let's set it up. Y equals, I don't know what A is. What are my two factors going to be based off of my roots?
0, 0, 20, 0.
Okay, so my factors, hey, when I say factor, I'm talking about the parentheses here, the binomial x with a 0, either. Or you could just do x. You don't have to have plus 0. And then what's the other one?
Minus 20.
Minus 20. Okay?
Oh yeah.
Okay, to be honest, I really think this would be easier to do. Not even put that plus 0, because it's just a 0. 0, 0 is the only time it's going to happen. Okay, now we have to have a point that is not a root 0 x-intercept solution. Do we have one?
500.
Here's the vertex. We don't want to guesstimate. We want to use ones that we actually know. So I'm going to plug in my vertex, which is, so use vertex, which is 1600 A times 10 times 10 minus 20. Ten minus 20 is?
Minus
10
10.
times negative 10 is? So it's A times 10 times negative 10. I rewrote that. I did the multiplication. I put it in front of the A. Just so I can solve it easier. It looks like a little bit prettier. What is 1600 divided by negative 100?
Minus 16. Probably minus.
Anybody in physics? Right now?
No.
No? In engineering? Have you seen A values of negative 16 a lot?
No.
Oh. Anybody know why the A value is negative 16? No?
For fun.
Ever heard of a thing called gravity?
No, never.
Okay. This is the the pull of gravity. Okay, and I think this is
Not sure what that is.
maybe this
I
is
don't know.
feet per second. I don't know, but a lot of times that you see these situations, yeah, feet per second. It's negative 16 feet per second or 9.8 meters per second. Physics people, I'm right. I remember that. Okay, but a lot of times in these situations, first of all, does it make sense that our A value is negative? Which way is our graph? Concave down. Okay,
down.
so that needs to happen. But the reason why it is negative 16 specifically is because of gravity. This is a real world situation. You're going to see a lot of problems later, like weeks later, but they'll have negative 16 x squared, blah, 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 blah. Okay, so what is our factored form? What are our two equations? Factored form, final answer, we're not done. We had to do all that work, but how would I write my factored form? Y equals negative 16 times, and you really didn't even have to put the parentheses around the x, but I mean, if we're keeping consistent with 2, you could write it a number of ways. I'll show you. Or negative 16x, x minus 20, or y equals negative 16. You don't have to write all of them. I'm just showing you. You could actually be a little extra and put the plus 0, minus 0, whatever. Okay? Can you write your vertex form now? Yes, you can. You know your A. It's the same A for all of them. You know your A. What's your A? Negative 16. In vertex, you put
Minus 10.
minus 10 squared plus 1600. So here's your two forms. If you were solving for vertex, I'll write that out. You could use, I would use an easier point. I would use 0, 0. You can use any point that is not the vertex. So you could use 0, 0 or 20, 0. And I'll work it both ways so that way you can see. Of course, there's only one. You find A one way. Like, you pick your way. But I will show by using vertex form as well. Okay? So in the practice packet, if you're not done with 4.1, you're behind. 4.2 has 8, 9, 10, 11, 12, 13. And again, you can go and put your answers into Delta Math. And I
Is 13 a fraction?
pray I did them right. 13 a fraction for A?
Yeah.
No,
I got a fraction.
I did not. I did not. Yes.